Learning objectives. At the end of this topic, you will be able to describe polygons, classification of polygons, diagonals, convex and concave polygons, understand regular and irregular polygons, angle sum property of polygons and sum of the measure of the exterior angles of a polygon, understand kinds of quadrilaterals, understand some special parallelograms. Introduction. A plane curve is a curve that lies in a single plane. A plane curve may be closed or open. A plane is a perfectly flat surface extending in all directions. Example: floor is a plane surface. It extends in all directions. A plane has two dimensions, length and width. All planes are flat surfaces. If a surface is not flat, it is called a curved surface. In this lesson, we recall the types of polygon and briefly discuss about different types of quadrilaterals. Different types of polygons. You come across different types of polygons in your lower class. Now let us review all the types here. Polygon is a closed two-dimensional figure formed by three or more straight lines. These are some examples of polygons, and these are some examples that are not polygons. Next, let us see classification of polygons. Polygons can be classified and named based on how many sides they have. In this table mentioned are the number of sides of the polygon and name of the polygon. Diagonal. A diagonal is a line segment joining two non-consecutive vertices of a polygon. Informally, any sloping line is called diagonal. Therefore, a quadrilateral has two diagonals joining opposite pairs of vertices. Next, we come to convex and concave polygon. A convex polygon is defined as a polygon with all of its interior angles less than 180 degrees. This means all the vertices of the polygon will point outwards, away from the interior of the shape. Concave polygons cave in to the interiors, creating at least one interior angle greater than 180 degrees. A concave polygon must have at least four sides. Try this. Adjust the polygon below by dragging any orange dot. If any vertex points inwards towards the center of the polygon, it ceases to be a convex polygon. What is the difference between concave shape and convex shape? Yes, you will note that the concave shape has the dent. Now we will see regular and irregular polygons. A polygon that does not have all sides equal and all angles equal. A polygon is regular only if all angles are equal and all sides are equal, otherwise it is irregular. In this triangle, all the three sides are equal and all the angles are also equal, so it is regular. In this triangle, the sides are not equal and the angles are also not equal, so it is irregular. These are some of the examples of regular and irregular polygons. Angle sum property. In your earlier class, you have learned angle sum property. Let us recall that. Do you remember the angle sum property of a triangle? Obviously, the sum of all the three angles of a triangle is 180 degrees. What about quadrilateral? The sum of the measures of all interior angles of a quadrilateral is also 360 degrees. Let us see some problems related to this type of quadrilateral. For example, from this figure, we try to find the value of x. We know that sum of the measures of all interior angles of a quadrilateral is 360 degrees. So we add all the interior angles here, that is 83 degree plus 107 degree plus 115 degree plus x is equal to 360 degree. When we add these, we get 305 degree plus x is equal to 360 degree. So, x is equal to 360 degree minus 305 degree. We get x is equal to 55 degree. Sum of the measures of the exterior angles of a polygon. Consider the polygon Two exterior angles can be formed at each vertex of a polygon. The exterior angle is formed by one side of the polygon and the extension of the adjacent side as displayed here. It is important to note down angle 1 and 2 are exterior angles for that vertex. Be careful as angle 3 is not an exterior angle. Sum of the exterior angles of any polygon is equal to 360 degrees, using one exterior angle as a vertex. If you're doing with a regular polygon, you can determine the size of each exterior angle by simply dividing the sum 360 degrees by the number of angles. Each exterior angle for regular polygon is equal to 360 degrees by n. Now let us look at some problems related to polygons. Consider the example. Find the exterior angle of x for the given polygon. We already know the exterior angle of any polygon is 360 degrees. So we write x plus 70 plus 88 plus 110 is equal to 360 degrees. When we add, we get x plus 268 degrees. So x is equal to 360 degrees minus 268 degrees. Therefore, x is equal to 92 degrees. Let us discuss one more problem related to exterior angle. Find the number of sides of a regular polygon whose each exterior angle has a measure of 60 degrees. We know that total measure of all exterior angles is equal to 360 degrees. Measure of each exterior angle is equal to 60 degrees. Therefore, the number of exterior angles is equal to 360 degrees divided by 60 degrees, we get 6. Hence, the polygon has got 6 sides. Kinds of quadrilateral. Quadrilateral. A quadrilateral is a four-sided polygon. Quadrilaterals can be of different shapes, but they all have 4 vertices. The sum of the interior angles in a quadrilateral is always 360 degrees. There are special types of quadrilaterals. They are Trapezium, Kite, Parallelogram. Let us briefly discuss about it here. Trapeziums are quadrilaterals with one pair of opposite sides, which are parallel and of unequal length. The other sides are not parallel. These are some examples of trapeziums and not trapeziums. The next is kite. Kite is a special kind of trapezoid. Its diagonals are perpendicular and cross at the midpoint of one of them. A kite is a quadrilateral. It has 4 sides. There are exactly 2 distinct consecutive pairs of sides of equal length. Parallelogram. Parallelogram is a quadrilateral. Opposite sides are parallel. Opposite sides are equal in length. Opposite angles are also equal. These are some examples of parallelogram and not parallelogram. Elements of parallelogram. In parallelogram, there are several rules involving the sides of a parallelogram, the angles of a parallelogram and the diagonals of a parallelogram. Basically, we know what are the opposite sides. In parallelogram, whose opposite sides are parallel. What is adjacent side? This means one of the sides starts where the other ends. CB and BA are adjacent sides. Angle A and angle B are adjacent angles. They are at the ends of the same side. Angle B and C, angle C and D, and angle D and A are all adjacent angles. Now let us see the property. The opposite sides of a parallelogram are of equal length. Consider a parallelogram ABCD. Draw any one diagonal, say AC. Looking at the angles, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Since in triangles ABC and ADC, angle 1 is equal to angle 2, angle 3 is equal to angle 4, and AC is common. So, by ASA congruency condition, So triangle ABC is congruent to triangle CDA. This gives AB is equal to DC and BC is equal to AD. Consider the example. Find the perimeter of the parallelogram PQRS. We know in a parallelogram the opposite sides have the same length. Therefore, AB is equal to DC is equal to 8 centimeters. BC is equal to AD is equal to 5 centimeters. So perimeter is equal to AB plus BC plus CD plus DA is equal to 8 centimeter plus 5 centimeter plus 8 centimeter plus 5 centimeter is equal to 26 centimeters. Angles of a parallelogram. Now let us discuss about the property of angles of a parallelogram. The opposite angles of a parallelogram are of equal measure. If AC and BD are the diagonals of the parallelogram, you find that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Studying triangle ABC and triangle ADC separately will help you to see that by ASA congruency condition, that is, if two angles and the included angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. Therefore, triangle ABC congruent to triangle CDA. This shows angle B and angle D have the same measure. In the same way, you can find the remaining angles. Next property is adjacent angles in a parallelogram are supplementary. Supplementary angles that add up to 180 degrees. Since angle A and D are adjacent angles. If we add the angle of A and D, we get a total of 180 degrees. Hence, angle D is the supplementary angle of A and vice versa. Consider the example. In a parallelogram PQRS, if measurement of angle P is equal to 80 degrees, find all the other angles. Given measurement of angle P is equal to 80 degrees. Then angle measurement of R is equal to 80 degrees because angle R and angle N are opposite angles of a parallelogram. Since angle P and angle Q are supplementary, measurement of angle Q is equal to 180 minus 80 degrees equal to 100 degrees. Also, measurement of angle S is equal to 100 degrees since angle S is opposite to angle Q. Thus, measurement of angle P is equal to measurement of angle R is equal to 80 degrees and measurement of angle Q is equal to measurement of angle S is equal to 100 degrees. Diagonals of a parallelogram. In general, a diagonal is a line segment joining two non-consecutive vertices of a polygon. We know that any sloping line is called diagonal. The diagonals of a parallelogram are not of equal length. Now let us see the property. The diagonals of a parallelogram bisect each other at the point of their intersection. This property is very easy to understand. Applying ASA criterion, it is easy to see that the triangle POQ is congruent to triangle ROS. This gives PO is equal to RO and QO is equal to SO. Consider the example. In a parallelogram ABCD, the length of OB is equal to 5 cm and AC is 6 cm more than DB. Find OA. Given OB is equal to 5 cm, then OD is also 5 cm. So DB is equal to 10 cm. Therefore, AC is equal to 10 plus 6, which is equal to 16 cm. OA is half of AC. So OA is equal to 1 by 2 into 16, we get 8 cm. Some special parallelograms. As we have already said, parallelograms are quadrilaterals with two pairs of opposite sides. Parallelograms can be divided into three further groups. They are rhombus, rectangles, and squares. Now let us briefly discuss about these special parallelograms. Let us first discuss about rhombus. Rhombus is a quadrilateral which has four equal sides. It is important to note that Kite is not a parallelogram. The sides of rhombus are all of the same length. This is not the case with a kite. Now come to the property. The diagonals of a rhombus are perpendicular bisectors of one another. We know that ABCD is a rhombus. Therefore, it is a parallelogram too. Since diagonals bisect each other, OA is equal to OC and OB is equal to OD. We have to show that measurement of angle AOD is equal to measurement of angle COD is equal to 90 degrees. It can be seen by SAS congruency criterion, that is, two triangles are congruent if two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of the other triangle. So triangle AOD is congruent to triangle COD. Therefore, measurement of angle AOD is equal to measurement of angle COD. Since angle AOD and angle COD are a linear pair, measurement of angle AOD is equal to measurement of angle COD is equal to 90 degrees. Consider the example. ABCD is a rhombus. Find the length of x, y, z. We know x is equal to OD is equal to OB, which is equal to 4 centimeters. Since y is equal to OA is equal to OC, which is equal to 10 centimeters. Z is equal to AB, which is equal to 12. Since all sides are equal, here we get Z is equal to 12. The next special parallelogram is rectangle. We already know rectangle is a quadrilateral with its opposite sides equal and all angles are also equal, which is 90 degrees. Now let us see the property. The diagonals of a rectangle are of equal length. If ABCD is a rectangle, then looking at triangles DAB and BCD separately, we have triangle DAB is congruent to triangle BCD. This is because AB is equal to AB, since AB is common to both the triangles. BC is equal to AD, since opposite angles are equal. Measurement of angle A is equal to measurement of angle B, which is equal to 90 degrees. The congruency follows the SAS criterion. Thus, AC is equal to BD, and in a rectangle, the diagonals, besides being equal in length, bisect each other. Consider the example. ABCD is a rectangle. Its diagonals meet at O. Find x if OA is equal to 2x plus 3 and OD is equal to 3x plus 2. OD is half of the diagonal DB. OA is half of the diagonal AC. We know that in rectangle diagonals are equal. So the halves are also equal. Therefore, 3x plus 2 is equal to 2x plus 3. 3x minus 2x is equal to 3 minus 2. We get x is equal to 1. The last special parallelogram is a square. Square is also a quadrilateral with 4 equal sides and angles are also equal. The square, like the rectangle, has diagonals of equal length. In a rectangle, there is no requirement for the diagonals to be perpendicular to one another. Consider the property. The diagonals of a square are perpendicular bisectors of each other. ABCD is a square. AB is equal to BC is equal to CD is equal to DA. Since angle A, angle B, angle C and angle D are right angles, we know that AC is equal to BD and AC is perpendicular to BD and OA is equal to OC and OB is equal to OD. Summary. Let's summarize the topic. A set of connected points is said to be a curve. A simple closed curve is a curve that does not intersect itself at any points other than possibly at the endpoints. A curve that begins and ends at the same point is called a closed curve. A convex polygon is defined as a polygon with all of its interior angles less than 180 degrees. Concave polygons cave in to their interiors, creating at least one interior angle greater than 180 degrees. A polygon is regular only if all angles are equal and all sides are equal. Otherwise, it is irregular. Sum of exterior angles of a polygon is 360 degrees. Trapeziums are quadrilaterals with one pair of opposite sides which are parallel and of unequal length. The other sides are not parallel. Kite is a special kind of trapezoid. Its diagonals are perpendicular and cross at the midpoint of one of them. It has 4 sides. There are exactly 2 distinct consecutive pairs of the sides of equal length. Parallelogram is a quadrilateral. Opposite sides are parallel. Opposite sides are equal in length. Opposite angles are also equal. The sides of the rhombus are all of same length and the diagonals of a rhombus are perpendicular bisectors of one another. A rectangle with its opposite sides are equal and all angles are also equal, which is 90 degrees. The diagonals of a rectangle are also of equal length. Square is also a quadrilateral with 4 equal sides and angles are also equal. The square, like the rectangle, has diagonals of equal length. The diagonals of a square are perpendicular bisectors of each other.